So chapter 7 is sort of a continuation of chapter 6. It's still trig, but we're going to be using some of the skills from chapter 6, but mainly learning some new skills. So in this chapter, we're going to be looking at trigonometric identities, inverse functions, and equations. So 7.1, we are going to start our exploration of identities, and this is going to take us all the way through to 7.3. So before we get started, what you need to make sure that you're okay with is how to manipulate rational expressions. So in Math 11 or Math 50, if you took it with us, you learned how to simplify, something like x minus 3 over x minus 3 times x, something like that, okay? What we're now going to do is do this exact same skill, but we're going to be doing it with trig. So if you are at all nervous about this, I recommend doing the just-in-times. So in these notes, I've put in a few of the just-in-times that I think you should work on. So a good place to start would be all the way from 18 to 21. Right? This is just reviewing what you can do with rational expressions, and it'll make you feel more confident when you're putting it with trig. So if that's something you need, pause this video, go right now, practice algebra with x's, and then when you come back, we're going to add in that layer of it being algebra with trig. So hopefully you've come back to this video or you're feeling confident and we can kind of run with this. So what I'm talking about is that this is a multiplication of two rational terms. So we've got sine x over cos x, and we're multiplying it by 1 over cos x. You have to remember that when you're multiplying rational terms, you just multiply across. So you multiply the numerators, you multiply the denominators. So sine x times 1 is sine x. And then cos x times cos x, right? It's just like going x times x. X times x is x squared. But instead of this just being an x, it's a cos x. So we're actually doing cos x times cos x, or cos x squared. Now, as you know, because I say it all the time, is that mathematicians are way too lazy to draw these brackets. So what they do instead is that it's known that if it's cos x times cos x, we can write it as cos squared x. So this means cos x times cos x. Never, ever put the squared on the x. It's the cos x term that's being squared. Okay. So now that we've reviewed how to multiply rational terms, now we want to look at, well, what about when you can simplify? So if you look at this expression, we've got cos x over sine x times sine squared x over cos x. The rule is you're allowed to simplify common factors that divide to give you 1. And what I mean by that is that this could be written as cos x times sine squared x divided by sine x divided by cos x. And you can change the order. In other words, I could read this as cos x divided by cos x. It's a common factor that can divide to give you 1. So same thing here, we've got sine squared x divided by sine x. And again, if you remember that sine squared x is really sine x times sine x, then you can simplify one of the sine x's. So sine x divided by sine x is 1. So in other words, all I'm left with is 1 times sine x in my numerator, 1 times 1 in my denominator. So this would simplify to just a sine x. All right, so pause the video, see if you can figure out what the answer to this one would be. Hopefully you did that. Okay, so we've got 1 plus sine x over 1 plus sine x as a common factor. Remember, when there's plus signs or minus signs, you have to stop. You can't take any of it unless you take the entire expression. So 1 plus sine x, 1 plus sine x matches, that makes 1. And then cos x goes into cos squared x and leaves just 1 cos x. And the answer would be cos x. Okay, so now what we want to do is move on from just simplifying rational expressions to a layer that's called simplifying with trigonometric identities. So an identity is an equation that's true for all possible replacements of a variable. In other words, it's something that's sort of set in stone, and we know that it's true. All of your trigonometric identities are on your formula sheet. Now, the formula sheet, everybody's got kind of a different looking one. I'm going to bring over the one that I use. Oops, sorry. I just want this to share my screen. Okay, so I'm going to have this on the side. So when you're doing chapter 7, honestly, your identity sheet is going to be right next to you all the time because you're going to use it that often. So on your trigonometric identity sheet, your identities are broken up into sections. We've got basic identities, we've got Pythagorean identities, sum and difference identities, cofunction identities, double angle identities, and half angle identities. For now, we're just going to deal with this top section, which is our basic identities. And they tell us things that we already know potentially, like cosecant x is the same as 1 over sine x, or secant x is the same as 1 over cos x, and so on and so forth. Maybe also a new one that you haven't used yet is tan x is equal to sine x over cos x, or cotan x is cos x over sine x. Okay, so these are all of these basic identities that you're allowed to replace something in your expression at any point in time. What I mean by that is that if we look at this expression here, we've got cos x times tan x minus secant x. And if I said to simplify this, you'd probably think, hey, I'm going to distribute my cos x through. So I could go cos x tan x minus cos x secant x. And for our skills right now, you'd be done. You'd be like, okay, I simplified, I multiplied through. But adding this layer of identities allows you to go further. I can replace any of these parts of the term, so any of these trig functions, with one of the basic identities. So for example, I could say, hey, tan x is actually equivalent to sine x over cos x. So if I rewrote this expression with tan x being sine x over cos x, can you see what would happen? All of a sudden, you could simplify cos x divided by cos x is 1. So if we do the same thing with this guy, we've got cos x, and then we've got secant x. Now, secant x can be replaced with 1 over cos x. Ah, okay. I'm going to make this bigger. So now, if you look at this, if I wanted to simplify, I could say this is cos x times sine x divided by cos x. Some people like to put the over 1. It helps them see it a little bit better. But really what I can see is cos x divided by cos x is 1. I can see cos x divided by cos x is 1. What am I left with? Well, for the first one, I'm left with sine x. And for the second term, I'm left with minus 1 times 1, or just 1. So I've made this expression simpler. And I did it not only by performing the operations, but also by doing trig identity substitutions. Okay, so I want you to pause the video, and I want you to give this one a go now. All right, so the first thing I would do is multiply through. And again, you don't, not again, but maybe you changed everything to sine and cosine first and then multiplied through. It's sort of personal preference. I do it differently every single time I do it, but the idea is that you can see the secant x and the cosecant x and think, ooh, I should change those to just sines and cosines, because usually things are in their simplest form when it's just sines and cosines, but you could multiply through first and then do that. It's up to you. So I'm going to do that. I get sine x secant x plus sine x cosecant x plus, now I'm going to distribute the cos x secant x, and then cos x, hopefully I can squeeze this, cosecant x. All right, now I'm going to use my basic identities to replace the things that aren't sine and cosine. So I'm going to replace the secant x, the cosecant x, the secant x, and the cosecant x. So again, if you didn't pause the video yet, now would be a good time to pause the video and just try that. Okay, but you should get sine x times 1 over cos x plus sine x times 1 over sine x plus cos x times 1 over cos x. Ooh, let's see if we can squeeze, plus cos x times 1 over sine x. All right, now what you need to be able to do is change or to simplify. So if we look at this, what can simplify? I've got sine x divided by sine x, cos x divided by cos x. Okay, so I'd be left with this one, nothing simplified, so I'm going to multiply across. So I'd be left with sine x over cos x. And then this simplifies to just 1. And then this guy simplifies to just 1. And then lastly, I've got plus cos x over sine x. All right, well, what could I do with this now? Well, it depends. So I kind of have a little bit of a love-hate relationship with 7.1. In 7.1, it's kind of like simplify. And you're like, well, when do I know if I'm simplified? For example, maybe I could just leave this as sine x over cos x. Maybe I'll move this term over to get cos x over sine x, but I can definitely collect like terms and get plus 2. Maybe I want to go further and say that sine x, I'm going to go back and say is tan x. Cos x over sine x is cotan x plus 2. You know, it's kind of like a guessing game of how do I know if I'm done? And my answer to that is if it's multiple choice, you're trying to turn your original expression into one of the answers. And then my better answer is that you're really learning these skills for section 7.3. And in section 7.3, there's actually going to be a right side. We're actually going to turn these into equations. And you're going to be making left side equal to right side. So your right side will either be this or your right side will be this, and you'll know to stop. So for now, just try to turn it into whatever the back of the book says would be my advice to you. But my short answer is just do your best, you know, or my long answer is look at the back and turn it into it. I don't know if that makes sense, but I do have a hard time with simplifying these because I never know when is it called simplified, right? But so here's an example of a question that I would potentially ask on a test or on a multiple choice, right? So here we've got an expression, tan squared y over secant y divided by 3 tan cubed y over secant y. And I want to know which of these following terms is not equivalent to this. Okay, so I'm going to simplify this expression and try to get 3 out of these 4 answers. So how are we going to do that? Well, the first thing I'm going to notice is this is division. So I'm going to take the second fraction and I'm going to flip and multiply. I'm going to work over here. So I'm going to say that this is tan squared y over secant y times secant y over 3 tan cubed y. Now you could change these right away out of tans and secants, but I feel like that's going to make things more complicated. I would first simplify. So if I look at this, I'm like, okay, I've got a tan squared on the top and tan cubed on the bottom. So I'm going to take out 2 of the tan y's and I'm going to be left with just tan y here. Okay, so I had tan cubed, I had tan y times tan y times tan y. Now I just have a tan y. And I'm going to simplify my secant y's. Okay, so everything simplifies to 1. What am I left with now, just after simplifying? Well, I'm left with 1 times 1 on the top and 1 times 3 tan y on the bottom. So automatically I know that this one is equivalent. Okay, so what about these other 3? So I have to find a way of turning this expression into these 3, well, 2 of the 3. So what can I do next? Well, if I think back to my basic identities, right, if I look at that formula sheet, I know that tan y and cotan y are reciprocal identities, meaning that cotan x is 1 over tan x or tan x is 1 over cotan x. So what that means I could do is say that if it's tan y on the bottom, it would be cotan y on the top. So I could go cotan y over 3. So if that doesn't make sense to you, if you need some more steps, you could write this as 1 over 3 times 1 over cotan y, right? So tan y is equal to 1 over cotan y, and then you'd have to divide to flip and multiply. But you can also just think of them sort of as reciprocal identities. If it's tan y on the bottom, it's cotan y on the top. All right, so what about the other 2? Okay, one of these is correct and one of these is incorrect. Which one's which? Well, you could go back to your 1 over 3 tan y and change tan y into sine x over cos x. Or you could look at cotan y and say, oh, there's an identity that says cotan y is equal to cos y over sine y. So I'm going to do that one. I'm going to say, okay, cotan y is cosine y over sine y divided by 3. Okay. Now, some of you might know that the sine y can just come to the bottom. If you don't, show the algebra. This is cos y over sine y divided by 3. Well, division is really just multiplication because we can write this as cos y over sine y times 1 over 3. And so I'd be left with cos y times 1 over 3 sine y. So I know that this one's a correct answer, which means that this one must not be. All right, last one. This one's kind of new to me. I had actually never seen these basic identities. Our old textbook didn't have it, but they are just basic identities. If you look on your formula sheet, you've got sine of negative x is equal to negative sine x, cos of negative x is equal to actually positive cos x, and tan of negative x is equal to negative tan x. And this all stems from, your cast rule, and all that kind of stuff you've learned, but at this point you're allowed to just assume knowledge. So this one had cotan and a cosecant. If you look at your identities, here I'll just split that screen again so that we can have them up. If you look at your identities, your basic identities, we don't have a cotan and a cosecant, right? We have a sine, a cosine, and a tan. So my first job is going to be turning these guys into one of these ones, right? Something that I can replace. So let's do cotan. So cotan is really 1 over tan. Cosecant is really 1 over sine. Now you could do your replacements at this point, okay? Or we could keep going and just make this into a simpler fraction. So this is a compound fraction. I'm going to rewrite it as 1 over tan negative theta divided by 1 over sine negative theta. Then I'm going to flip that second fraction. So 1 over tan theta times sine of negative theta. So that's going to leave me with sine negative theta divided by tan. Oops, I forgot my negative. Sorry about that. Negative theta. Now I can replace. So sine of negative theta is just going to be negative sine theta. Tan of negative theta is going to be negative tan theta. And then lastly, I'll just make my screen big so I can fit it. Lastly, I can do a negative divided by a negative is a positive and write this as sine theta over tan theta. Now, am I fully simplified? I don't think so. I think we could go further and say that tan theta is sine theta over cos theta. And then I'm going to do the flip and multiply thing again. Wow, I really needed more room. Sine theta divided by sine theta over cos theta. Then I'm going to change it to a multiplication. So it'd be cos theta over sine theta. And then I can simplify. So sine theta divided by sine theta is 1, and I would be left with just cos theta. So, that got messy. I apologize. But the biggest thing that we're doing is changing cotan and cosecant into one of my basic identities. So I had to change it into either sine, cosine, or tan, which I've done here. Okay, then I change it to a single fraction. So some people might know at this point, they could have gone a shortcut and said, hey, if it's cotan on the top, it's going to be tan on the bottom. If it's cosecant on the bottom, it's going to be sine on the top. So that could be a bit of a shortcut if you start to see it. Otherwise, do the long form. And then, sorry, this would be a negative again. And then you could proceed from there. But the idea is you're trying to make it as simple as possible. A general rule of thumb is that if everything's sine and cosine, it's probably going to be as simple as it can because you've probably taken out all the common factors you can. That's why when I was left with the sine over tan, I was like, ooh, maybe I could go further. And so when I changed the tan to sine over cos, yes, it went further. So there's a lot to this. Again, there's the rules that come from rational expressions on how to multiply and simplify rational expressions, including compound rational expressions, dividing rational expressions, and so on. And then there's this new layer. The new layer is that you can also replace terms. So you can use these identities to replace things that could help you go further in simplifying.